is that the engine is less noisy, which is a good thing, by the way. The new hydrogen engine has the same torque as a diesel engine, meaning it can generate enough power to handle difficult conditions. Its peak efficiency is, however, slightly higher than in diesel engines. We expect that JCB engineers worldwide won't encounter too many difficulties when working on hydrogen engines, as they're quite similar to diesel engines. In fact, the capacity and bottom end of JCB's hydrogen engines are exactly the same as those of diesel engines. So how does the JCB hydrogen engine work? In the hydrogen engine, the traditional diesel injectors are replaced with hydrogen injectors and a spark plug. Hydrogen, having a much lower density than diesel, is injected at a lower temperature and pressure compared to what is achievable in diesel engines. Unlike diesel engines, this engine does not auto-ignite, and this is why a spark plug is included in the engine to ignite the fuel. For combustion to take place, there has to be a perfect mix of hydrogen and air inside the engine. According to Tim, this homogeneous mixture is to be achieved in 28 milliseconds. To do this, a high-efficiency turbocharger with low inertia is included to get more air into the engine very quickly. Burning air at a particular temperature can lead to the production of nitric oxide. But with the low temperature and pressure of combustion in the hydrogen engine, these emissions will not be created. Ultimately, the hydrogen engine is a much cleaner alternative to diesel engines. There's zero carbon combustion inside the engine, leading to zero CO2 emissions. The byproduct of the combustion reaction inside the engine is steam, which comes out through the exhaust. This steam, which Ryan Ballard refers to as dry steam, is managed within the engine using a special oil. This oil doesn't form an emulsion in water and keeps water vapor away from the engine. Also, refueling JCB's hydrogen engine is quite simple. Most heavy-duty machines are fueled on-site from bunkers that are capable of storing large amounts of fuel. A Bowser is basically a tank used to transport fuel to heavy-duty machines. This same principle is applied to hydrogen combustion engines, and JCB has already built a hydrogen storage tank with the capacity to hold 100 kilograms of hydrogen. It's designed to operate at a pressure of 500 bars with a machine pressure of 350 bars. This way, the process of refueling doesn't require a pump, as it is essentially a decantation process. And so, in just a few minutes, an empty tank can be filled with hydrogen fuel comfortably. But beyond refueling, there's a bigger challenge, and that's getting hydrogen fuel. This has to be the biggest challenge when it comes to switching from diesel-powered engines to hydrogen fuel. Diesel fuel is readily available, but where do we get the hydrogen fuel to power these new engines? Hydrogen, which is the most abundant substance on Earth, isn't readily available in its pure form, and only pure hydrogen can be used as fuel. It is, however, safe to say that JCB has its eyes set on the future. Having developed an engine that runs on clean hydrogen fuel, the next challenge will be making green hydrogen easily available. However, on a more optimistic note, many countries have started making advances toward the production of hydrogen fuel. And while we're still a long way away from a world with zero carbon emissions, it's clear that progress is being made. But why even bother towing the hydrogen fuel path? Toyota also believes very much in a hydrogen-fueled automobile future, so JCB is not the first to think of a hydrogen-dominated future. Well, we believe it's simply because of the many benefits of hydrogen engines. Apart from the scarceness of hydrogen fuel, we're convinced that hydrogen engines are better than diesel engines. With hydrogen fuel, we have a much cleaner alternative to diesel and gasoline. The net CO2 emission from hydrogen combustion engines is zero. The chemical reaction that takes place inside the engine is void of carbon, with dry steam being the byproduct. Again, hydrogen-fueled combustion engines do not require any significant adaptation, at least from drivers. The vehicles operate in just the same way as those with diesel engines. And interestingly, hydrogen engines, according to JCB, are slightly more efficient. Additionally, when considering power and torque, they plot a similar curve to diesel engines. Compared with electric batteries, hydrogen engines have more economic value for heavy-duty machines. They also do not contribute significantly to the net weight of the machine. Electric batteries capable of producing the required amount of energy to power big machines tend to be too heavy, and these batteries would also occupy just too much space. The engineers at JCB believe that hydrogen-powered machines are the future, and though we were a little skeptical about how it was going to work some years back, their new engines have gone a long way to convince us.